wherever they begin. It's time for that. Okay, so we plug in the -1. And when we did this before in grade 10 and grade 9, we made tables of values, correct? We'd plug in an x, we get a y. We plug in an x, we get a y. We plug in an x, we get a y. We graph the graph, right? We just get a whole bunch of coordinates. We started in grade 9 doing this. That's all we're doing here. We're plugging in for x, -1. -1 cubed is -1 times -1 times -1, which is still -1. If you punch it into your calculator as -1 cubed, not in brackets, it'll tell you it's -1, which is true. But if you punch in -1 squared, not in brackets, it'll tell you it's -1, which it's not. So you have to make sure that you actually put it in brackets if you're going to put it into your calculator. Or you can just use your math skills and go -1 times -1 times -1 is -1. So we get P of -1 equals -1 plus 4 times +1 minus 1 minus 6. So P of -1 equals what? -4. Now what I tell you, in grade 10 we did this all the time, and in grade 9. You'd plug in an x, you get a y. What is that? It's just a coordinate. It's an xy coordinate. The xy coordinate is -1 and 4. Is that an x-intercept? What's the key thing to x-intercept? Y equals 0. That's why this gives us the remainder as well. The remainder happens to be -4. But we also need it to be 0 in order for it to be an x-intercept, because then our coordinate would be -1 and 0, and then that would be a x-intercept. So is this an x-intercept? No. Is this a factor? No. The remainder is, oops, -4. I should say negative. The remainder is -4. So it's not a factor. It's also not an x-intercept because the coordinate's -1, -4. It's not -1 and 0, is it? Okay. So we're going to look at number 2. Divide, write this down, x cubed plus x squared minus x plus 3 by x minus 1. What is the remainder? So remainder theorem states that if I take the supposed x-intercept, or the value of x for that factor, and I plug it in, what's left over will be the remainder. So right now I have x minus 1, but that's not x equals, is it? It's x minus 1. So I have to set it equal to 0 and solve for x. X minus 1 equals 0, so x equals 1. So now I'm going to find P of 1. So the remainder theorem states if I take what x equals, I plug it in for all the x's, it gets me the remainder. So I'm going to get 1 cubed plus 1 squared minus 1 plus 3. So P of 1, 1 plus 1 minus 1 plus 3. So P of 1 equals what? 4. So what's my remainder? So if ever I ask you for the remainder, this is the fastest way. If I ask you to factor it, though, you actually have to do a different method, right? But if I just ask for the remainder, you plug it in, give me an answer. Now, what's my coordinate? 1, 4. So is 1 an x-intercept? No, it would have to be 1 what? 0. So this is not an x-intercept. Is x minus 1 a factor? What's the remainder? 4. What does the remainder have to be in order for x minus 1 to be a factor? 0. Is it? No. You try number 3. So for this one, we have x plus 2 equals 0. So x equals -2. So if we get negative 2, 0, it's an x-intercept. Therefore, x plus 2 is a factor. Okay? So we're actually finding coordinates as well. So we do p of negative 2 equals 2, negative 2 cubed, minus 4 times negative 2 squared, plus 3 times negative 2, minus 6. So we're going to get 2 times negative 8, minus 4 times 4, minus 6, minus 6. So we get negative 16, minus 16, minus 6, minus 6. Is that negative 44? So my coordinate is negative 2 and 44. Is that an x-intercept? Negative 44. Really don't want to write the negatives for some reason. Not an x-intercept. What's the remainder? Is x plus 2 a factor? Okay. I'm going to flip ahead and come back in a second here. So when you fill the number into your polynomial, the x equals into your polynomial, you get the remainder, right? So if I ask you on a test, what's the remainder, you could just plug it in and give me an answer, and we'd be done. If I asked you, is it an x-intercept or is it a factor, you plug it in, get the remainder. If it's not 0, it's not. Okay? What happens if, and we'll come back to the other ones in a second, I give you this. So do this one. Find the remainder when 2x cubed plus 3x squared minus 7x minus 3 is divided by 2x plus 5. It's in factored form right now, but in order to fill it in, we need it in x equals form, correct? So we have to set it equal to 0 and solve for x. So now we're going to plug negative 5 halves in. If we plug anything into our calculator, we need it in brackets. So we're going to do p of negative 5 halves, which equals 2 times negative 5 halves cubed plus 3 times negative 5 halves squared minus 7 times negative 5 halves minus 3. When you plug it in, you get 2. So this is a coordinate negative 5 halves and 2. I know my remainder, if they ask me, when I factor that, is 2. I know then that this is not a factor because my remainder needs to be 0. And is my remainder 0? No. It's 2. So it's also not an x-intercept. It's a coordinate, negative 5 halves and 2, or negative 2.5 and 2. Okay? So knowing that knowledge, we're going to be able to do stuff with it. So Don't worry about writing this stuff. So we have when x cubed plus 5x squared plus kx minus 8 is divided by x minus 3, the remainder is 1. And then they're going to say find k. So they're going to have this, and then they're going to say find k. So up until now, we've had a full polynomial, we've had a factor, and then I've asked you for the remainder. Now they're giving us a polynomial with a missing variable, and they're giving us a factor and a remainder and asking us to find that missing variable. Correct? So the remainder theorem states that if I take this factor and I solve it, so x minus 3 equals 0, I get x equals 3. We just said that if we fill that in for the polynomial, it's going to equal what? What has it happened? It equals the remainder, which is 1. So whenever they give you the factor and the remainder, you can plug them in, right? P of 3 is going to equal the remainder. We agree? Now, is there anything I can do now? What does P of 3 mean? What have we done when we have that? X equals 3 in the polynomial. So we just go to the polynomial, we plug in 3 for all the x's, and in this case, it's going to equal what? 1. That's it. Then we'll only be missing one variable, which is the k. Let's try it out. So we're going to get 3. P of 3 means 3 cubed plus 5 times 3 squared plus k times 3 minus 8 equals 1. Right? The only variable I'm missing now is k. So just solve for it. So 3 cubed, 27. Plus 9 times 5, 45. Plus 3k minus 8 equals 1. We're going to collect like terms. 27 plus 45 is 72. Minus 8 is 64. And then plus 3k equals 1. Now I want to solve for 3k. So what am I going to do? Close. Yeah. Subtract the 64 over. We do reverse bedmaster rules when we solve. 3k equals negative 63. Divide by 3. K equals negative 21. How could I check this? Yeah. Put the negative 21 back in for k. Plug 3 in for x. And what should I get for an answer? 1. If I plug negative 21 in for k, I plug 3 in for the x's, my answer should be the remainder, which is 1. So you can check it. I want you guys to try number 5. So we have P of 3 equals 12. So that means x equals 3, and the remainder is 12, correct? That's another way of saying it. Or what could they have said the factor is? Divided by what? X minus 3. And then they could say the remainder is 12. Find k, correct? That's another way they could say it. Given that P of x is divided by x minus 3, the remainder is 12, find k. So we are going to go P of 3 equals 12. So 3 cubed minus k times 3 squared plus 17 times 3 plus 6 equals 12. 27 minus 9k plus 51 plus 6 equals 12. 51 and 27 is 78 plus 6 is 84. Subtract 84. Negative 9k equals negative 72. Divide by negative 9. K equals 8. Check it out. You plug it back in for k. You could plug in 3, and then you should get 12, right? All right. What happened? So in this case, we were missing k. We were missing one variable, correct? What happens if we're missing 2? Okay. So in this case, we have, write this down, when p of x equals 3x cubed plus mx squared plus nx minus 7, so we're missing an m and an n in this case, is divided by x minus 2, the remainder is negative 3. It is also known that p of negative 1 equals negative 18. Find m and n. So in the past, we were only given one factor, one remainder, but we were only missing one variable. In this case, we're missing m and n. We're missing two variables, so we need two factors technically, two divisors, which you're dividing by, and remainders. Neither of those are factors. Why are neither of those factors? Why is neither x minus 2 or x plus 1 a factor? The remainders are what? Not 0. Okay? So we're going to do the exact same thing, but we have to do it twice. So we have divided by x minus 2, the remainder is negative 3. So that means p of what equals negative 3? When divided by x minus 2, the remainder is negative 3. P of what? P of positive 2, because when we solve it out, we get positive 2. Put a line. The next one is p of negative 1 equals negative 18. What could they have wrote? When you divide by x plus 1, the remainder is negative 18. They could have written it like that, correct? Okay. We're going to plug them each in separately. So we have 3 times 2 cubed plus m times 2 squared plus n times 2 minus 7 equals negative 3. Now the last one we got k by itself, but here we have two variables. We can't get them by themselves. We can get the two of them by themselves, but we can't solve that way. So what we're going to do is we're going to get the variables by themselves on one side and the number by itself on the other for both equations, and then we're going to have to do an extra step, which we learned in grade 10, and we used in grade 11. 2 cubed is 8. 8 times 3 is 24. 2 squared is 4. 4 times m, 4m. Plus 2n minus 7 equals negative 3. I want to keep these on this side and move everything else to the other. 24 minus 7 is 17. Subtract my 17 over. 4m plus 2n equals negative 20, and then I'm going to box it. I can't solve for either of them because I don't know either of them right now. Now I'm going to repeat the exact same steps for the other one. 3 times negative 1 cubed plus m times negative 1 squared plus n times negative 1 minus 7 equals negative 18. Negative 1 cubed is negative 1 times 3. It's negative 3. Negative 1 squared times m is just m. Negative 1 times n is negative n minus 7 equals negative 18. M minus n minus 10 equals negative 18. M minus n equals negative 8. Remember when you had linear system and a linear system in grade 10? How did you solve them? Your teacher gave you 3 methods. You only wanted to stick with one, and you were annoyed that you were taught 3. And we could ask you to do it either way, and you'd have to be able to do it because it's in the curriculum. Elimination or substitution or graphing. In this case, it says algebraically, so you're going to have to do elimination or substitution. I always pick elimination because it's the easiest because I already have them in the form of elimination. Mn equals number. Mn equals number. So I just stack them on top of each other. So I'm going to get 4m plus 2n equals negative 20. M minus n equals negative 8. Are either the m's or the n's the same? You know, if I add or subtract right now, will either of them go away? It's called elimination because you're eliminating a variable. It's actually quite a good term for it. So you need to eliminate a variable. Which one do we want to make the same, the m or the n? If you make the m the same, I would multiply the bottom by negative 4m. Why would I multiply by negative 4, not m? Negative 4. Because then I could add them. 4 minus 4, add them, cancels. Or if I want to make the n's the same, what would I multiply by? Just a 2, because then I could add them and they'd cancel. Okay? I'm going to do the n's. If you did the m, it doesn't matter. What does matter is that you multiply the entire bottom equation by it. So we get 4m plus 2n equals negative 20. 2m minus 2n equals negative 16. Most people forget to do it to the 8. Now, if we subtract, we'd get 2n minus a minus 2n, which would actually be 4n. So subtracting is not helpful in this instance, but addition is. If I add, I get 6m, and what happens to my n's? They cancel or eliminate, hence elimination. Okay? Equals negative 36 divided by 6. M equals negative 6, which is great. However, the question asked me to find m and n. Substitute it back in to either equation, right? I'm going to pick the second one twofold. 1, because it looks easier, and 2, because it has space below it for me to fill in the negative 6. So I'm going to get negative 6 minus n equals negative 8. Negative n equals negative 2. N equals 2. Will there be something like this on your test? For sure. Is it ridiculously hard? No. It's just time consuming. How could I check if I was right? Plug the m back in, plug the n back in. For all the x's, I would plug in one of those. So negative 1 or 2. And I would look for the remainder. Yeah. As long as you do it to both sides. You're just making it more complex. You're just not simplifying. You're just expanding. So you can do it as long as you do it to both sides. Because if I take, say this was x's and y's, which was easier to understand when we were, if they were x's and y's, so I had the equation x plus y equaled 6. Say I multiplied it by 2. 2x plus 2y equaled 12. If I solve this one for y, or I solve this one for y, you get the exact same equation. As long as you do it to both sides. All right. That's your homework. Insert 14. 14 and 15 here are the long ones. Polynomials, really nice unit. Polynomials, really bad unit, you don't do your homework. Don't be like, oh, this is easy, I'm not going to do my homework. You should be like, oh, this is easy, I'm excited to do my homework. That's what you should do. That should be what your little brain thinks, or large brain. 14 and 15 are just like what we just did. They're just the longer ones. We have to solve two variables.